A colorful morning to one and all. Once again, a warm welcome to Sai Chaitanya Iit Academy. Today's topic is kinematics. So, in order to study about the kinematics, we want to know some of the important branches in physics. So, some of the important branches in physics. So, one of the important branch in physics is mechanics. Second one, classical physics. Third one is modern physics. Atomic physics. Thermodynamics. Optics. So these are some of the important branches in physics. In order to understand or in order to learn about the kinematics, first we want to take the branch that is mechanics. So mechanics. Mechanics, no doubt, it is a branch of physics. Here it deals the motion or the rest condition of the object. It deals about the rest or motion condition of the object. So whether the object is at rest or whether the object is in motion, and this mechanics is going to say the condition of the object. So mechanics, it further classified into three types. This mechanics further classified into three types. First one is statics, second one is kinematics, and the third one is dynamics. Here statics, the name itself indicates static means rest. Here this statics deals the bodies which are at rest. Here the static, it is a branch of mechanics. Here it discusses the bodies which are at rest. When you come to the kinematics, here it discusses the bodies which are in motion. Dynamics, it is also discuss the objects which are in motion. Here kinematics, it describes the object which are in motion. Dynamics, it is also discussing the objects which are in motion. What is the difference between kinematics and dynamics? Means here in this kinematics, it does not explain the cause of motion. It does not explain the cause of motion. In physics, for a body to get into motion or to get into rest, some external cause, that is force, is necessary. The concept of force is not explained by kinematics. But when you come to the dynamics, it explains the motion of the body and the cause also. Here, it is going to explain the cause, how the body comes into motion or how it explains by cause of motion. Here the force is taken into consideration. We are going to differentiate kinematics and dynamics within another example. For example, take a cap and release the cap. So in kinematics, we are going to discuss what is the velocity. What is the velocity of the cap after 2 seconds, With what velocity it touches the ground? What is the time taken to touch the ground? These are the topics that we are going to discuss in the kinematics. Actually, we are not going to discuss why the cap reaches to the ground from the top. So the main reason why the cap touches the ground from the top means gravity force. Here the gravity force is not explained by kinematics, but when you come to the dynamics, here in this dynamics it explains the gravity force as well as what are the conditions that we have discussed in the kinematics that are also going to be explained by dynamics. This is the main difference between kinematics and dynamics. Kinematics, it explains the motion without cause. Dynamics explain the motion of the body with cause, considering the force. This is the main difference between kinematics and dynamics. Now we will see what is kinematics. Kinematics explain the motion of the object without taking the consideration of force. Now we want to know the word motion. So in order to have a clear idea about the motion, we want to discuss about one more word, that is rest. So if you discuss rest, if you understand the word rest, we can understand the word motion. So we are going to try to understand the word rest. For example, take a cap. With reference to me, the cap is not changing its position with the time. So the cap is said to be in rest. If you observe the same cap from reference to the moon, the cap will be moving because the earth is rotating. So due to earth rotating, the cap is going to change its position with reference to the moon. So with reference to the moon, the cap is said to be in motion. With reference to me, the cap is said to be rest. So now we can say the definition for rest and motion. Rest means if the position of the body does not changes with respect to the surroundings, then the body is said to be at rest. The motion is quite opposite to rest. So if the position of the body changes with respect to surroundings in a given time, that is motion. Motion. If the position of the body changes with respect to the surroundings in a given time, then the body is said to be in motion. Actually, we cannot exactly say whether the body is at rest, under, or in motion. Sometimes the body which is at rest may appear to be in motion. That we are going to observe with a small example. Let us consider this is a vehicle. Let A and B are the two persons who are sitting side by side. C be the another person who is on the road. Let us consider the vehicle is moving like this. Now, if you observe the B person with reference to the A, the B is at rest. Why means they are in the same vehicle. But the same person B, when he is he is observed with the C, he is in motion. So Person is same B, but he is going to appear rest and motion depending upon the reference. So here, in order to say whether the body is at rest or motion, one thing is important, that is frame of reference. So with this frame of reference only, we are going to say whether the body is at rest or motion. Absolutely, we cannot say whether the body is at rest or motion. We can say only by the frame of reference. What is a frame of reference? It is an coordinate system. By using this, we can say whether the body is at rest or motion. So that which describes a coordinate system which describes whether the body is at rest or motion, that is known as frame of reference. Frame of reference is a coordinate system which describes whether the body is at rest or motion. So here motion is classified, once again classified into three types. That is one-dimensional motion, two-dimensional motion and three-dimensional motion. So what is one-dimensional motion, what is two-dimensional motion and what is three-dimensional motion? That is going to be explained by using this coordinate system. So first we are going to see what is one-dimensional motion. This one-dimensional motion is also known as straight line motion. So what is one-dimensional motion? Here one-dimensional motion means if the motion of the body is confined to single direction. Here the motion of the body will be confined to single direction. That means the body moves from left to right or right to left, or if the body moves from bottom to top or top to bottom. Now, for example, if you release a cap, it is changing its position along the y-axis. That is, it is changing the position in this manner. So at t equal to 0 seconds, the body will be here. At t equal to 1 second, the body may reach here. T equal to 3 seconds, the body may reach here. T equal to 5 seconds, the body may reach here. Here, the body is changing its position in only one direction. So in order to represent this change in position among these three coordinates, here y coordinate is sufficient. So in order to explain the motion of the body, a single coordinate is necessary. Then it is known as one-dimensional motion. In the same way, if the body moves from left to right, like this. Here at t equal to 0, the body will be here. At t equal to 1 second, the body may move here. At t equal to 2 seconds, the body may move here. Here, the body is changing its position, okay, in only one direction. In order to represent this change in position, we required only one axis, that is x-axis. Here we required only one axis, that is y-axis. Here only one axis, that is x-axis. Here in these conditions, in these two conditions, we require only one axis to explain the motion of the body. Such types of motions are known as one-dimensional motion or straight line motion. Example, all the vehicles which are moving on a straight road, these are all the vehicles, the motion of the car, motion of the lorry, whatever may be, if it is moving in a straight line, in order to describe the motion of that body, and single axis is sufficient, hence it is known as one-dimensional motion. In the same way, now we are going to see two-dimensional motion. dimensional motion. So the name itself indicates. Here we require two coordinates in order to explain the motion of the body. How? Means, for example, when a body is moving in a circle like this, let us consider this is a frame of reference. So when the particle is here, it had moved some distance along the x-axis. Let us say it is x-axis and it is y-axis. Now we are taking the particle is here. When the particle is here, it has moved some distance along the x-axis and it has moved some distance along the y-axis. Here the motion is in two directions, that is along the x-axis and y-axis. If you take the particle here, it has moved the distance of x this much and y this much. So here when the particle is here, this is the movement of the body along the x-axis. When the particle is here, this is the movement of the body along the x-axis. So here, in order to represent the position of the particle, we require two coordinates, that is x coordinate and y coordinate. So such type of motions are known as two-dimensional motion. And in order to explain the motion of the body, if it requires two coordinates, then it is known as two-dimensional motion. The best example is circular motion. In the same way, whatever the motion which takes place in a plane, that comes under the example for two-dimensional motion. In the same way, when you kick a football, the football follows the path like this. That is projectile motion. So when you take let us consider the football is at this position. Now it has moved some distance along the x and it has moved some distance along the y. In order to represent the position of the football, we are requiring two coordinates, that is x coordinate and y coordinate. So such type of motion is known as two-dimensional motion. If in order to represent the position of the body, if we require two coordinates, then it is known as two-dimensional motion. So the best example is circular motion. For two-dimensional motion, the example is circular motion. At the same time, projectile. Projectile. What is a projectile? For example, take a cap and if you throw like this, it is going to follow like this. It follows parabolic path. So projectile motion, circular motion. For example, if you take ant, it is moving on the surface of the table. It is considered as two-dimensional motion. In the same way, three-dimensional. No need to represent in the form of frame of reference. If the motion is in space, if the motion of the body is in space, it is three-dimensional motion. And in order to represent the motion of the body, if we require three coordinates, then such motion is known as three-dimensional motion. For example, motion of a motion of a kite, motion of a bird. So these are all the example. Motion of aeroplane. These are all the example for three-dimensional motion. So these are the three types of motion: one-dimensional motion, two-dimensional motion, and three-dimensional motion. In order to study kinematics completely in one-dimensional or two-dimensional, we require some parameters or some terms. So what are the terms required in order to study the kinematics completely in one-dimensional and two-dimensional? Means parameters are: number one, distance, displacement, speed and velocity, acceleration, and kinematic equations. So if you know these parameters, we can study completely the kinematics in one-dimensional as two-dimensional. These parameters are going to be discussed in the next class. Until then, have a nice day. Bye-bye.